Welcome to Imaginary and Complex Numbers. Today we're going to look at simplifying, adding, subtracting, and multiplying imaginary and complex numbers. We begin by introducing the imaginary value I. I is defined as the square root of a -1. Recall really quickly when we were doing some radical work and we recognized that if you took the square root of -4, we knew that we could not find any real root because 2 squared is +4, -2 squared is still a +4, so we were at the point where we couldn't understand what is it that you would square to get -4, and we decided that there was no root for that situation. Today we are now going to be able to explain how we can still take the root, in this case square root of -4, by using the imaginary unit I. So to begin illustrating how we're going to use the imaginary unit, here's another example. We're going to look at the square root of -9. We know there's no real roots, so this is how you apply the imaginary unit. We begin by breaking down the square root of -9 into -1 times 9. So what we're doing is factoring out the negative out of the 9 as -1. Then we further simplify. This is otherwise written as the imaginary unit I. The square root of 9 is 3. And then to finalize that, we always write the coefficient value in front of the imaginary unit. And so the square root of -9 is equal to 3i. To explain where imaginary values fall in the grand scheme of numerical values, here's a quick little Venn diagram. We have a very large group of numbers here that we call the reals, abbreviated with this fancy R. And then we have a bunch of number groups inside the reals. We've got our natural numbers, which is 1, 2, 3, 4, 5, all those values you learn when you're probably 4 years old or 5. Then we have the whole numbers, abbreviated as W. That includes the 0, 1, 2, 3, 4, 5. The Z group are the integer groups, which now also add the negative integers into that group with the whole numbers. Then we have Q as the rationals group, so anything that can look like a fraction. So you've got your integers plus your fractions and decimals on the number line, and then we've got all our reals. Then we have a different circle here that merges with the reals, but part of it is not in the real number system, and that is the imaginary number. So the part on the outside are the imaginary group of numbers, and then the part that merges with the reals, which is the a plus bi here, those are called the complex numbers, and we'll look a little bit at those in a minute here. A little bit more practice on using the imaginary unit to simplify the square root of negatives. So again, you factor out the negative square root of -1 out of the value, and that will always get written as I. That's how we write the square root of -1. Then the other part of the radical, which is now the positive 125, gets broken up into simple radical form as we've been using it before. So 25 is a square number in 125 that goes in there 5 times. Simplify the square root of 25 as 5. And then when you're putting this all together, you're going to have the outside value, the imaginary unit following that, and the radical at the end. So this is the simplified version of the square root of negative 125. It is an imaginary number. Here is another example. Break this up into the square root of negative 1, square root of 18. Square root of negative 1 is simplified as I. This is broken down into square root of 9 times square root of 2. Simplify the square root of 9 as 3. And then putting this all together, you've got your coefficient, your I, and your square root of 2. Working with imaginary units, another popular value that we'll use is the I squared. I squared is basically the square root of negative 1 squared, which is equivalent to negative 1. So this actually turns this imaginary value actually into a real value once it gets squared. We're now transitioning to complex numbers, which is made up of a real part and an imaginary part. The real part would be this value right here, and then the imaginary part is the value that's got the I. So it's a combination, plus or minus, of a real and an imaginary number. We're going to do some adding and subtracting with complex numbers, then we'll also do some multiplying. So a couple process rules here. Adding and subtracting, you're basically going to add the real parts and then add the imaginary parts, and you'll probably be left with a binomial expression. When you're multiplying, you're going to just remember the distributive property and FOIL when you've got binomials that are multiplying. And this is where we'll actually need to use this definition here for I squared. So anytime I squared shows up as you're simplifying, you'll always want to replace it with negative 1 and finish the simplifying with that value. Here's an example of a subtraction problem. So this looks a lot like what we did with our polynomials. What you're going to want to do is take the subtraction and change the signs to everything that follows it. So this becomes a minus 10 and a minus 8i. Then you identify your like terms. So your numbers, your real parts go together, and then your imaginary parts go together. So for our answer here, we're going to have negative 7. That's the 3 minus 10. And then you're going to have minus 13i, negative 5 plus negative 8i. So you end up with this expression here that's got a real part and an imaginary part. Here is an example of multiplication, and you've got two binomials. So you'd have to apply the FOIL method or just distribute, distribute, distribute. So for our multiplication, we've got 2 times 8, which is 16. Then you have 2 times the 4i. And remember how we talked about multiplication is pretty flexible here. So you can multiply a real value to an imaginary value. You just multiply the coefficients. So you get a negative 8i. In your inner, you've got the imaginary times this real number 8, and that's doable as well as a positive 40i. And then you'll have the 5i times the negative 4i, which will be a negative 20, and I times I is I squared. So once the multiplying happens, you simplify, and here is where the I squared here gets simplified as negative 1. Not in the radical, just a regular negative 1. That is multiplying to the negative 20. So that actually becomes positive 20. Your like terms here will combine your I values I. So this will become a 32I, and 16 will come down, and then last but not least, recognize you've got still some more like terms to combine. So that will give you 36 plus 32I.